Hello everyone. So today let's solve the problem 877 stone game, right? So let's see what the question states here. So Alice and Bob alternately take an entire pile, right? From either end of the row of even length piles. They have given even length piles, yeah. Each pile has positive stones. Each pile has, see here, each pile has positive stones, yeah. So see here, 5, 3, 4, 5, all are positive numbers, right? Each pile has positive stones and the total sum is odd, and the total sum is always odd. Yeah. So you can just sum up here. 5 plus 3, 8, 8 plus 4, nothing but 12. 12 plus 5 is 17. 17, right? This one. Each pile has positive stones and the total sum is odd. No tie, right? No tie, they have strictly mentioned. So here both play optimally and we have to return true if Alice ends with a more stone, right? If Alice ends with a more stone, then we have to return true. Else we have to return false. Yeah. So here we have been given 5, 8, 5, 3, 4, and 5. Alice starts first and can only take the first 5 or the last 5, right? Accordingly with the question. She suppose she takes the first 5, this one, first 5, so that the row becomes 3, 4, 5 here. So we are left with the 3, 4, 5, right? If Bob takes 3, suppose the Bob's take next 3, right? So then the board is 4, 5. We are left with a 4, 5. And Alice takes 5 to win with a 10 points, 5, 10. So Bob can only take 4, right? So Alice will win with a 10 points. If Bob takes the last 5, then the board is 3, 4, and Alice takes 4 to win with 9 points. Even if the Bob takes this one 5, Alice will win, right? So it will be 8 and 9 respectively. Alice will quite obviously win. This demonstrated that taking the first 5 was a winning move for Alice. So we return true. Yeah, in this case. Yep. Alice wins right here by taking the first 5 here. So in this case, we have to return Boolean value true. So same goes with the example 2 as well. You can just check out in the same way, right? This is fine. Yep. So yeah, let's do one thing. Let's quickly discuss the approach followed by the complexities and then let's write the code, right? So before this one, moving on with the approach, let me tell you one thing. We will be making use of the 2D DP to solve this particular problem. Yeah, dynamic programming, nothing but the 2D DP to solve this particular problem. Yeah, first, let's go with the approach. The first thing here, as I've said, we'll be making use of the 2D DP, right? So we will be making use of the 2D DP where DP of ij is equivalent to the maximum score difference, maximum score difference. Yeah. So here I can just represent in this way. DP of ij is nothing but it is equivalent to the maximum score difference. I'll just write here maximum score difference. Yeah, this is the first step. So we'll be making use of the 2D DP and DP of ij as we are considering the this one 2D DP. DP of ij is equivalent to the maximum score difference, right? So base case will be DP of double I is equivalent to the piles of I because uh, only one pile, the current player can take only one pile initially, right? So I can just write it in this case. So I'll just write it here, this one base case. So this one will be DP of II equals initially the base case, right? So this one will be piles of I. So I'll just write here P of I, nothing but the piles of I. So this is fine. Let's move on with the third step actually. So see here, let me tell you one more thing here. Transition is nothing but choosing the left gives piles of I minus dp of I plus 1j, right? Opponent then place optimally on remaining, right? Remaining ones actually. Choosing right, choosing left gives piles of I minus dp of I plus 1 into j. What if the opponent, this one, the guy chooses right actually. Sorry, not the opponent, the guy chooses right. Then piles of j minus dp of I j minus 1. Yeah, this is the thing actually. See, choosing left actually, let me write it over here. Choosing left actually gives piles of I minus dp of I plus 1 into j. dp of I plus 1 into j. This is fine. And what if choosing right actually? Choosing right is equivalent to piles of j minus. So this one I'll just write it over here like this. Piles of j minus dp of ij minus 1. dp of I, this one will be j minus 1, right? So this is fine. J minus 1. So this is the main thing actually. Yeah, let's implement the same thing on the example one. So let's consider the example one. Whatever we discussed now, the idea, let's implement the same thing. So as I've said, we'll be going with a 2DDP, right? First thing is here for this particular example, let's go with a single piles here. First, initially DP of 0, 0 base case, the DP of 0, 0, we will initialize this one to 5, right? But DP of 0, 0 will be 5. We have 5 here. So DP of 1, 1, what we will do with the DP of 1, 1 here? DP of 1, 1, we will set this one to the 3, the next value. And DP of 2, 2 is nothing but the 4, this one. DP of 2, 2, let's set this one to the 4, right? So this is fine. Just give me a second here. DP of 2, 2 is set to 4. And finally, the last one, DP of 3, 3. The value we have is 5 actually. Let me assign this one to 5. Yeah. This is nothing but the single piles. So for the length 2, it is DP of 0, 1, max of 5 minus 3. This one, max of 5 minus 3 and 3 minus 5, right? So max among the 2 and minus 2 is quite obviously 2. For we will be going with the DP of 0, 1, DP of 1, 2, and DP of 2, 3, right? So the value will be 2, 1, and 1 respectively. For the length 3, it would be max of 5 minus DP of 1, 2, nothing but the value. We'll consider the max. So total for the length 3, we will get 4 actually. We'll get 4. Yeah. So this is what we'll be doing single piles length 2 as well as the length 3. Next we will consider full actually DP of 0, 3, uh, then DP of 0, 2, that we will do. Finally what we'll do, we'll compute DP of 1, 3 is, that is equivalent to the max of 3 minus DP of 2, 3, and 5 minus DP of 1 basically. Yeah. So overall we'll be getting actually here in this case 1 itself. Since DP of 0, 3 is greater than 0, Alice wins here. So since DP of 0, 3 is greater than 0 here, Alice wins in this case. So we'll carry on with the same steps for the length 1 as well as the length 2, right? I mean length 2 and length 3. Sorry, this is 1, right? This one. Actually, single piles we are considering length 1. So length 2 and the length 3, right? So then we will be getting DP of 0, 3, which is greater than 0. Here in this case, as DP of 0, 3 is greater than 0, Alice wins actually. Yeah. When Alice wins, what we have to return? We have to return the value, Boolean value true. We'll return Boolean value true. So the output that we got here is true, which is equivalent to the output that they have mentioned for the example one within the question, right? Our approach works absolutely correct here. Our approach works absolutely correct. So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would lead to big of n square. Yeah, the time complexity would lead to big of n square, right? So why it is big of n square here? So we will fill an n into n dp table and each cell is computed in big of 1. So overall time complexity would lead to big of n square. So what would be the space complexity here? Space complexity would lead to big of n square as well, because we will be storing the this one 2D DP table of size n into n. Yeah, overall space complexity would lead to big of n square itself. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n square and big of n square respectively. Now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. Yeah. First, let's go with a number of files. So this will be int n equals files dot length. Yep. The next step would be let's initialize the DP. As I've said, we'll be making use of the 2D DP to solve this problem. Let me initialize the DP. New int of, so this one will be n into n we are making use of, right? Size n into n. This is fine. The next step would be let's go with the base case for the single pile intervals as discussed in the approach, right? So this one will be for int I equals 0, I less than n. Let me increment I here. So within the for loop, if only one pile current player picks it, right? So this one I can just write it in this way. DP of I equal equals piles of I actually. This is fine. So let me come out of this one entirely. Now, as usual, as we are going with the 2D DP, let's build the DP table for the lengths from 2 to n. So this one will be for int length equals 2, length less than or equal to n, then plus plus. Yeah. This is fine. Now, one more for loop because we have to start this one. We have to go with the I as well, right? I is nothing but the starting index of the sub array. So this one will be for mm, int I equals 0. So this one I have to go with I mm, less than n actually, I believe. So this one, let me consider one more thing here, or let me write it in this way: I plus length minus 1 less than n. So this one also I can just write it in this way as well, I believe. Yeah. Now j is nothing but the end index of the array, right? So let me assign j to I plus then minus 1, nothing but the length minus 1. So this is fine. Next, uh, we accordingly with the this one approach that we discussed, the player either he will pick left or he'll pick right, right? So we have discussed this one already. So I can just write it in this way: int pick left equals, what if he picks left? So this will be piles of I minus dp of I plus 1 minus dp of I plus 1. So let me write it over here in this dp of I plus 1 into j. So this is fine. And also, what if he picks right? If what if the player picks right? So this one will be pick right. So this one will be, we have discussed this one, piles of j minus dp of uh, I into j minus 1. Yeah, this is fine, I believe. I showed this one in the approach. So this is fine. Next, we have to choose the action that gives the maximum advantage for the current player, nothing but for the Alice, right? So I can just write in this way: dp of ij is equivalent to math dot max of, let me go with the pick left or end pick right. Maximum we have to consider, right? From either pick left or pick right variable that we have considered. So this is fine, man. So let me come out of this one entirely. Now, if the final difference is greater than 0, then Alice, first player, has more stones and wins. So I can just write here, return dp of 0 and n minus 1 greater than 0. So this is fine, I believe. Let me format the code and let me hit the submit button directly, thinking that it will work. Have it, have, yeah, uh, I had clicked this one, submit, thinking that it will work. So yeah, you can clearly see here, all the test cases are getting passed. Means whatever the code that we have written works absolutely correct for all the test cases. So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.